In this video, we will see how to reshape a data frame from wide to long, or in other words, how to convert columns into rows. We will use the Pivotlonger function to do this. In the picture on this slide, you can see an illustration of the kind of result we want to achieve. We want to take a wide data frame like the one on the right with lots of columns and reshape it into a long data frame like the one on the left with lots of rows. What we do is very simple. We take all the columns we want to convert and stack them into a single column. You can see here that we're taking the 1999 and 2000 columns on the right, each of which has 3 rows, and we've stacked them into a single column with 6 rows. It's important to note that we're not losing any data here. We had 6 cells of numbers before, and we have 6 cells of numbers afterwards. However, the observant among you will have noticed that there was useful information in the column names of the original columns, 1999 and 2000. Those tell us the year in which those data were collected, and we don't want to just throw that information away. So what we've done is create a second column which stores the column name of the original column. In this example, we've created a new year column to hold the column names that each of the stacked cells came from. For example, we can see the value 745 for Afghanistan originally came from a column called 1999. And so after pivoting the table, we've stored 1999 in the corresponding years cell for that observation. Here is how we would use the Pivotlonger function. There are 4 arguments that we must provide. As with all functions, these go inside the parentheses after the function name. For ease of reading, I have broken these arguments down over multiple lines. Normally, R would run each line of code separately, but here it sees the opening parenthesis of the function on the first line, and so it knows that everything that comes after on subsequent lines must be part of the same line of code until it reaches the closing parenthesis of the function. The first argument of the function is the name of the data frame that we want to reshape. Here I am calling that name of dataset, but obviously you would want to replace that with whatever variable your data frame is stored in. The nice thing about the data frame being the first argument is that it means we can pipe the data frame to the function, as you see in the second code chunk. When R runs this piece of code, it will insert the thing being piped in as the first argument of the Pivotlonger function, and bump all the other arguments up one spot. So even though cols looks like it's the first argument, it will actually be the second argument when the function is run. This means that if we have another function whose output is a data frame, such as mutate or filter, then we can pipe the output of those functions to Pivotlonger. In this way, Pivotlonger can become part of a longer sequence of functions that apply a series of transformations to a dataset. Next, we want to specify the columns to stack on top of each other, and so convert into rows. We supply this information to the cols parameter. In this example, I am stacking just 2 columns. In this imaginary dataset, these are called column 1 and column 2. And to list a series of columns, you can separate them by the vertical bar symbol. But there are many other ways of listing the columns as well. For a full list of these, you should check out the documentation for the Pivotlonger function. As I mentioned earlier in this video, we will create a new column that holds the names of the original columns. Because this is a new column, we need to tell the Pivotlonger function what it should be called. Here we're going to call it name_column, but you can call it anything you like. In general, it's a good idea to call it something that reflects the data that's actually in it. You should also note that this column does not exist yet, so, as far as R is concerned, this new column name is a piece of data, not an existing column name or variable. And as the column name is made up of a series of characters, this is therefore a piece of character data, and so it needs to go inside quotation marks. Likewise, we also need to specify the name of the new column which will hold all the data from the stacked original columns. This name we supply to the values_to parameter. Again, this needs to be inside quotation marks because the new name is currently just a piece of data, not an existing column. So these are the 4 main arguments we need to provide to Pivotlonger. The function also has other parameters which allow you to customize its output even more, and if you're interested in exploring those, you should check out the function's help page. Next, let's look at an example of how we can actually use the Pivotlonger function to tidy up the messy dataset that we saw earlier. As a reminder, this messy dataset was split into two tables, and each variable was broken up into different columns by year. Our goal is to convert this back into the tidy data frame from the previous video. Here you can see the code that we are going to use to do that. We are piping each data frame to be the first argument of the Pivotlonger function. Inside the function, we then specify the columns to stack on top of each other, the name for the column of original column names that we're going to create, and the name for the column of stacked values that we're going to create. Take a moment to refer back to the previous slide and make sure you can see where each of these arguments are coming from in those two tables. And a common mistake that I see a lot of people make is this. Remember that this function never modifies the original data frame. In this way, it is just like all the previous data wrangling functions that we've learned about. For example, here we are pivoting the population df and cases df data frames. But neither of those original data frames will be changed themselves. The output of the Pivotlonger in both cases is a completely new reshaped data frame. You will either need to pipe that to another function to do something else to it, or assign the output to a variable as we have done here. If you don't assign the output will simply be printed out below the code chunk and then thrown away. The output of these two Pivotlonger functions will be these two longer tables of data. But there is one last problem here. Our data is still in two separate tables, which is a problem given that it's really part of the same dataset. To combine the two tables back together, we can use a function called LeftJoin. We won't go into detail here about how this function works, but essentially it matches up similar rows in the two tables. For example, both original tables had a row for Afghanistan in 1999. As the data in both of these columns is the same in both tables, these two rows would get joined to form a single row, with a separate column for cases from the left table, and a separate column for population from the right table.